So the synthesis of aspirin, we will need, of course, salicylic acid. We'll also need acetic anhydride. And in order for this reaction to occur during the required time period, we're going to be using sulfuric acid as our catalyst. And just to keep in mind, of course, right, please note that acetic anhydride is actually in excess, and therefore our limiting reagent in this experiment is salicylic acid. And so what are we going to be using? So I've already pre-weighed 2.1182 grams of salicylic acid. I'm going to go ahead and transfer it directly to my Erlenmeyer flask. This is our Erlenmeyer flask. I want to make sure that I'm adding the entire quantity of the salicylic acid. And then in addition to that, of course, right, I'm going to be adding the acetic anhydride. I'm going to actually pour as slowly as possible to see if I can, of course, wash some of the solid that's adhering to the walls of this container down. So I've added, of course, our 4 mLs of acetic anhydride, which, of course, is in excess. I'm just going to swirl for a minute and then go ahead and add our 5 drops of concentrated sulfuric acid. Sulfuric acid, of course, is just being used as the catalyst. Catalyst, of course, in chemistry just increases the rate of that chemical reaction. So it's going to allow this, of course, to occur within that 20-minute period. So I'm going to transfer this now over to our hot water bath, and then we're going to heat for about 20 minutes. So in order for this reaction to actually go to completion, we will need to place it in a hot water bath for approximately 20 minutes. So right now it's clamped in place. And for my heating source, I'm using, of course, a hot plate, and I'm slowly immersing our Erlenmeyer flask into a beaker of hot water. And I'm going to allow it to sit here for approximately 20 minutes. Upon completion, we will then add our cold water to initiate the crystallization process. So after 20 minutes of heating, I'm going to remove, of course, the reaction vessel from the hot water bath. I'm going to, of course, transfer it to a wire gauze. And we're going to allow it to cool for a few seconds. And then I'm going to go ahead and add 10 mLs of that chilled water. So in chemistry, a lot of our experiments oftentimes require ice cold water. And so in order for you to make this ice cold water, you will need to first make, of course, an ice bath. And that just involves getting some ice and water. And then, of course, with a beaker or a graduated cylinder or an Erlenmeyer flask, you'll add your solvent, place it in for it to cool. So this has been cooling out for approximately, I would say, honestly, 20 minutes. And so I'm going to obtain 10 mLs of my ice cold or my chilled water. And then I'm going to slowly, in about 1 to 2 ml increments, I'm going to be adding that, of course, to our product. The goal here is that we're going to be initiating crystallization. This will also eliminate, of course, any acetic anhydride that is remaining and convert it, of course, to acetic acid. I'm then going to allow this to cool and then continue adding H2O just to break up that. So after adding the 10 mLs of chilled water, I'm going to transfer my reaction product to the ice water bath. to allow us, of course, to crystallize our sample. And that will be here for approximately 15 minutes. So now that the reaction or aspirin has crystallized, I'm going to go ahead and add our 25 ml of chilled, this is already chilled water. And the purpose of this is just to break up our aspirin so that I can, of course, then go separate it using the vacuum filtration. And it's already cold, but I'm going to still let it just sit here in this cool bag just to make sure I get the perfect crystals at the end. In the meantime, I'm going to prepare for our vacuum and filtration setup. And so here I'll need a filter flask. We also need a business funnel, a filter adapter, and this is of course connected to our vacuum pump, which is over here at the line. And what you're going to do, of course, is that when I pour the solution in the crystals, by making the vacuum, once you start putting the vacuum, the liquid will pass through, and our wonderful crystals, right, will remain on that filter paper. And so I've already pre-weighed, so you will see, of course, I've already pre-weighed our filter paper and our wash glass. I'm going to transfer that pre-weighed filter paper to the business funnel, and just to make sure that it stays in place, I'm going to just add 1 or 2 ml of water to hold that paper in. No freeze note, I'm using this one for chilled water. If I use warm water, that will actually hydrolyze. And so I'm going to go ahead now, and by means of vacuum filtration, I'm going to collect our beautiful crystals. And so using a stirring rod, I'm going to transfer, and this is going to have a hard time seeing this, I'm going to transfer in our reaction mixture to the business funnel. What is over here could actually be a clear colored solution, but somehow it appears to be a bit cloudy, but I can see that we have not lost any of our crystals, so I'm going to continue on with this process. So I'm transferring the aspirin to, of course, the business funnel. Now you'll notice that there is, of course, a solid along the walls of that container. And so to remove that solid, I'm just going to aid use this by adding a few drops of cold. Make sure now it's cold water, because if I use warm water, it's going to start dissolving, right, our crystals. If you want to be very careful, you can actually just chill this for a minute or two, just to make sure we get some beautiful crystals. Perfect. And you can go ahead and just add no more than 1 or 2 ml at a time. We also don't want to add too much water, because we want to make sure that we avoid dissolving, right? Each step along the way, please note that I'm using cold water. So this water is actually extremely cold. And then again, I want to do my best, make sure that we're removing as much crystals as possible. I'm going to go ahead and allow the vacuum to pump on our solid for a few minutes, maybe about 5 minutes or so, to aid in the drying process. After that, I'm going to transfer the filter paper and the solid to the watch glass and then reweigh. That second mass will actually be the mass of the filter paper, the watch glass, and our crystal. So in this part of the experiment, we're going to be testing for purity to see if, of course, we have any unreacted salicylic acid, of course, as a byproduct. And so if you recall, right, we said earlier that your phenolic compounds in the presence, of course, of iron forms a deep purple color. It doesn't have to be deep purple, but it forms a really dark color. And so what I have here, of course, are 3 test tubes. The first, of course, is our control. This is just ethanol in the presence, of course, of iron, that iron chloride solution. Remember, it is iron that is required, right, for the formation of that deep colored complex. So that's my control. And the second test tube, right now, is just my control. In a few seconds, I'm going to be adding aspirin to that. And then in the third test tube, what we also have, right, is also ethanol, that 1 drop of iron 3 chloride, but I've already gone ahead and I've added the salicylic acid. Now, salicylic acid, right, is a phenolic compound, so you have that aromatic ring with that OH group, and so what you'll notice here, right, is the formation of that deep colored complex. So I'm going to add just a crystal or 2, not too much is required, of our sample of aspirin, and let's see how pure our sample is. And I'm hoping that, yes, it's going to be colored, but hopefully it will be much lighter than just pure salicylic acid. So I'm going to take a minute, I'm going to mix that around. So I'll certainly say that you can see the formation, right, of a colored complex, but our sample is more or less fairly pure. Should we go ahead and consume this aspirin? Absolutely not, right? Because in the laboratory, I can assure you that there's lots of impurities still in our final product. But it's more or less fairly pure, right? Compared to only a small amount of salicylic acid is possibly present, compared, of course, to salicylic acid, pure salicylic acid. So the mass now of the watch glass aspirin and the filter paper is 28.359 grams. I should also point out to you that prior to this, of course, I also pre-recorded the watch glass and the filter paper, and that mass was 25.816 grams. So the difference between those two, between 28.358 and 25.816 grams, will give you the mass of aspirin. That mass, of course, is the actual mass that you obtained, and the theoretical mass, of course, is based on that balanced chemical equation. And then finally, the last step in this experiment requires us, of course, to heat our sample. And so if I remove a small amount, of course, of aspirin, and if I place it in a test tube, and if I heat it, of course, using a Bunsen burner, what you will be able to detect, of course, is the smell of vinegar. And the reason for that is that when aspirin is broken down, right, at high temperatures, it forms, of course, acetic acid. And acetic acid is that weak acid that is present in vinegar. So if you have, of course, an aspirin tablet sitting at home for an extended period of time, you might actually, of course, detect, of course, that vinegar